Hi, I'm Dr. Pete, and what follows is a short video that precedes the first laboratories that we will complete, hopefully this fall, when we're past the COVID-19 thing and back in school. So first there will be a short section on how the laboratory bench is set up in general, and then we will have a short safety discussion, and then I'm going to demonstrate the first laboratory of the year, which is the flame test, which we use in this particular class to identify cations in unknown solutions. Okay, so here you can see the standard setup for the bench, including reagents that are going to be used in the short demonstration of the flame test lab. So we have your trash bin. Anything trash-wise can go in here except for paper towels, which generally should be thrown out in the trash bin that you'll find at the back and the front of the class. Next, we have the centrifuge, which we're not using today, but you will be using in subsequent laboratories as we go forward once we're back in the building. We have a bin that holds plastic pipetters. You're going to be using these extensively this year. We have a beaker that has wooden splints, which we're going to be using on and off all year long. Then we have, each bench is going to have this plastic container that holds things like litmus paper and the test tube holders that we utilize to hold on to. Yeah, you guessed it, test tubes. We also have a Bunsen burner, which happens to be running right now because I'm about to demonstrate this laboratory in a minute. There will be a bin that also has the test tubes that you'll be using in it. Every bench on either end will be set up with a waste container that has water in it. This is not meant as a trash bin. You'll be using this to put out flaming splints. And then finally, you have, every bench is going to have a test rack with test solutions in it to identify different cations and anions. All right, quick safety lesson for today's video. You saw me just turn off a Bunsen burner because I want to demonstrate how I turn it on. But basically, in the chemistry laboratory, no matter what type of experiment you are going to do, safety is always an issue. And I would say flat out that the two things that will correlate with all the laboratories that happen in a normal chemistry class over the course of a year, understanding that you're going to be working with chemicals, and anytime you're exposed to chemicals, you should be in the habit of washing your hands and wash them frequently. In the laboratory setting that we're in here, you can see that there is a faucet. Let me just turn that a little bit on the ends of each bench. Also, there are faucets located in other locations, and once we're back in the building, we will talk about where those sinks are located. There's soap there, and there are paper towels located also on all the benches, so that you have no problem washing your hands, right? So when you're handling chemicals, even though they're always offered to you in containers, you need to be washing your hands off and on throughout the whole laboratory and make sure that you're keeping clean. The second thing is the Bunsen burner. All right, we're always going to be having fire in the lab. It'll be rare when we don't. And so you need to be careful working around it. If you get burned, the thing you need to do is go directly to the sink immediately. Don't come running to the instructor and say, oh, I burned myself. You need to go directly to the sink as quickly as you can get there, turn on the cold water, and then take the appendage that was burned and put it in the stream. Put it in the stream of cold water and keep it there for several minutes, right? And if you're quick about this, you can usually avoid having any sort of burn symptoms remaining if you're quick about it. Okay, let me dry my hands and we'll move to a demonstration of the experiment. Okay, very quickly, there are two ways that the Bunsen burner is going to be lit. Over the course of the year, I'm going to expect all students to learn how to light a Bunsen burner using the classic clicking device, which generates a spark when you know how to use it. All right, so what you're going to do is turn on the gas first. All right, and then you use the clicker to light the Bunsen burner. All right, another way to do it, which is by the instructor, is to use a lighter. And the flame from the lighter is placed near the bottom. In other words, where the gas comes out of the Bunsen burner. So now that we have this running, what we're going to do is run through the flame test. Remember that the reason why the flame test works is because all atoms, depending on how many electrons that they have different energy levels. And when we energize a particular element, electrons can be forced from a low energy level to a higher energy level where those electrons have higher potential energy. And they aren't going to stay in the higher energy level. So when those electrons drop back down, the energy that they had previously gained is now going to be released. And it will be released as light energy. And the light that is released will be colored to reflect literally the energy of that particular light that is being released based on that energy gap. So the flame test can be used to actually identify certain elements. We are going to focus on group 1A and group 2A elements because they produce a nice colorful spectrum that can be recognized by the naked eye. Now, the way that we're going to do this is we're going to use a wooden splint. We're going to get the splint wet using pristine deionized water. Deionized water has no cations or anions in it. It's clean. The only thing that it has is pure water. So I'm going to dip my stick in here and get it wet. Then I'm going to grab a cup which has a particular cation as a full ionic compound. So I'm holding sodium chloride in my hand right now. And what we're going to do is visualize the flame that's produced when we energize this particular compound. And the coloration that we see is because of the electrons that will be shifting in the sodium cation from a low energy level to a high energy level. So I take my wet splint, I place it in here, and I get crystals on the tip of this. And then we place it in the top of the flame. And you should be able to see that what we have is a bright orange. It's actually pretty darn close to a yellow flame. And the yellow flame is indicative of sodium ion, Na+. Now, you can see that this thing is smoking and it has a coal on it. So I'm going to put it out in the water. All right, and then I'm going to take my stick because I want to reuse these. I'm not going to be wasteful. And I'm going to break the stick off at above where the wetness was before. And then I'm going to throw this away, this thing, in the trash bucket, not in the container that has the water in it. Next, I'm going to grab the next element in question, which happens to be lithium ion in the form of lithium chloride. Lithium chloride. Again, I'm going to get my splint wet. Then I'm going to place it in the salt. And then I'm going to wave it carefully in the flame. And you can see that lithium produces a beautiful red flame. There is a little bit of orange in this, but you have to be careful because you can see I'm actually starting to burn the splint, which causes a yellow tint. But that would be an artifact of the experiment because I am lighting the splint on fire, which you want to avoid when you're doing this. So again, I'm going to put the splint out and I'm going to throw this thing in the trash now. I'm going to obtain a new splint. I'm going to get it wet. All right, and I'm going to redo the lithium so you can see that the orange color was in fact coming from the salt. Boom, red, boom, red. Do not light the splint on fire. All you're going to do is confuse yourself. Okay, good. Now what I'm going to do is take it and break the splint right above where the wetness was. Throw this in the trash bin. All right, I'm going to now get the splint wet again. Now we're going to analyze strontium. All right, wave it in the top. And you can see that we've got actually red and orange here. Red and orange. Red and orange. Put it out. That was mostly orange. But there were red streaks in it. This is something you're really going to have to pay attention to because I'm going to expect you to identify cations out of unknown solutions. Now we're going to look at potassium, KNO4. And we see that it's purple. It's a purple color. Potassium is purple. Break the splint above the dryness. All right, we're going to wet this down again. Now we're going to do barium. Wave it through the top. And you can see the barium is silver green. Silver green. Barium is silver green. All right, put it out. There's not enough of the splint left to use it again. You throw it in the trash, not in the water bin, not in the sink, in the trash. All right, new splint. I'm going to get it wet. The next cation we're going to test will be calcium in the form of calcium nitrate. The coloration that we see is because of the calcium, not the anion. Wave it through the top, and we can see that we have sort of an orangish red flame. I call this sort of dirty orange. All right, I'm going to break this off, and I'm going to do that one again for you. All right, again, calcium nitrate, we're looking at the emission spectrum, the type of light emitted by calcium when it's energized. And again, I call this sort of dirty orange. It's deep orange with red colorations. Calcium and strontium can be hard to tell apart. That's your job. Okay, let's now take a look at the next one. And we're going to look at the emission spectrum, or the light generated by copper when it's energized. Right? Green with some yellow in it. Green with some yellow in it. Not to be confused with barium. Barium is silver green. Copper, as you can see, is green with some yellow in it. Put it out. Where does it go? In the trash bin. Not in here and not in the sink. All right, and that concludes the lesson. In the last segment, I demonstrated to you 7 different elemental flame tests. And if it comes up, I need to tell you right now that yes, you are required to know the colorations of each of those cations. We eventually will get back into the physical building here, and then you will actually do that test for yourselves. Nevertheless, you still need to know them. So I'm going to quickly review right now. You need to have out paper and pencil. You need to go back in the video and go through it a few times and make sure that you can identify the colorations of the 7 elements in question. For sodium, it's an orange-yellow flame, more yellow than orange. It's very bright, it's clear-cut. For lithium, it's usually a very red flame, like a bougainvillea flower. Very red flame. Sometimes you can see some orange coloration feeding into it depending on the chemical preparation from which company. Calcium is usually dirty orange. There can be red in it, again depending on the preparation. Barium, silver green. You can't miss it, you can't mix it up. It's a silver green flame. Strontium is fairly red, but can be cut with quite a bit of orange, and sometimes can be confused with lithium. Again, it depends on the preparation that you're utilizing in the flame test. So strontium, generally speaking, is red with some orange in it. Lithium is way redder, period. Potassium is a purple flame. Purple flame. Distinguished from any of those other cations out of 1A or 2A. And finally, copper, as you saw, is green. There can greenish blue and there can be orange streakage in it, again depending on the preparation that it's coming from. Copper and copper and barium oftentimes are confused by students, but generally speaking, the students that are confused by the two have not done their due diligence on learning the flame test, and that's why they're making the confusion. Barium is silver green, no question about it, and it's easily distinguishable between that and copper. Copper is greenish blue and there might be a little bit of orange in it. You don't see that with barium, all right? Okay, in this video, what we're going to do is now we will apply what we just learned. So we went through the crystalline compounds, the ionic compounds that had cations in them that we can identify based on the flame test. And now that we know the colorations, we want to apply this to a real world problem, which is the following. You will be given solutions by me. I will be giving you solutions, and those solutions will have unknown ionic compounds in them. In other words, I have dissolved something in here, but you don't know what it is. And we want to use the flame test to figure it out. But we have a problem. So what's going to happen is during the laboratory is I'm going to give you an unknown solution. In this case, it's a colorless solution. And I'm going to just say, for the sake of the lesson here, that there's only one chemical compound in here. It's an ionic compound that has a cation that we can identify by the flame test. But here's where things get complicated, because I just taught you the flame test using pure salts of these compounds, and you can see how nice the coloration was. But when you dissolve these compounds in water, it creates a problem, because the solution itself cannot be identified in the flame, right? You can see that. There's no coloration here. What are you going to do? So what I'm going to do right now is train you how to do what's called the Muarka method. And this was developed by an 8th grader several years ago in order to flame test cations that are in solution that cannot be identified by just waving the wet splint that was dipped in the unknown in the flame. So what are we going to do? We're going to take some of the unknown. Quite frankly, we're going to count out 20 drops. All right. We need a test tube holder. All right. And we're going to get, actually I can use this splint because you saw there was no coloration before. And we're going to put the splint in here. Then what we're going to do is we're going to heat this. And the purpose of the heating is to drive the water into water vapor. And what we want is to evaporate the water off of this, leaving behind the crystalline solid. And then we're going to flame test the solid. Now you can see we're almost there. I keep driving that water off because I want to get down to the crystalline solid. I've still got steam coming out. All right, let's see what we got here. Sodium. Let me do that again. I'm going to clean this up, right? Do what I taught you. We're going to break it above the water. Okay, this one's not working too well. So I'm grabbing another splint in the interest of time. I'm going to insert it in here. And I'm going to scrape around in the solid, which is now at the bottom of the tube. And then flame test it. Sodium. Whereas before, we could not get a signal. So the Muarka method is used when we know we have a 1A or a 2A cation ionic compound that has been dissolved in water. We cannot get the signal for it, right? Then we use the Muarka method. We evaporate the water, leaving the solid behind, which is now crystallized on the splint. And then we wave that through the flame, and we can see what, in fact, the cation is based on knowledge about which colorations happen. All right? And that concludes our lesson for today.